In this video lecture, we're going to take up writing research questions. This is the second part of the discussion about how to do this. So let's review what we talked about in the first part. We talked about the difference between basic and applied research. We talked about the two basic questions for any research project, 3 audiences for research, the scientific method, and vocabulary terms that are related to research questions. In particular, we needed to talk about research questions, what they are, a hypothesis, a one or two-tailed hypothesis, what a theory is and how it differs from a hypothesis, an independent or dependent variable, a nominal or ordinal variable, and correlation and causation. We're actually going to put those ideas to work now when we talk about putting together research questions and hypotheses. So let's talk about what is going to come up in this video lecture. We're going to talk about inventing a research topic. We're going to talk about inventing research goals. We'll talk about phrasing research questions. And we will also talk about phrasing hypotheses. Once we get done talking about these in the abstract, we'll run through an example. So let's talk inventing research topics first. What does this mean and how do you do it? Well, the big idea here is that you need to find some sort of topic, a very broad topic, that might interest you to, do a research study about. Now, when you start thinking about research topic, what exactly am I going to study? It doesn't matter. You actually just need to keep it pretty broad at first. So, for example, ask yourself, do I notice any issues with blank in my personal or professional life? Since this is a technical communication class, we could say, any topic related to technical communication, just stick in that blank. If you want to take this to another discipline, just go ahead and put whatever discipline it is, stick it in that blank. So, do I notice anything going on? Another question you might ask is, what have I read in literature, or what have I encountered in my classes that makes me say, why is that? And also, ask yourself, is there a topic that nobody talks about, even though it seems obvious that we should talk about it? Once you've identified some sort of broad topic that you might be interested in, invent some research goals. Research goals are your general objectives in terms of doing research. So what generally do you want to come up with? What generally do you want to find out? So this is where you start narrowing the topic. Ask yourself this question. What's the problem with the topic I've identified? Then do yourself a literature review. Start looking through sources. Find out what other researchers have done. What have they written? What have they said? What are their conclusions? What are they investigating? Then, once you've done that, you can start to identify gaps in the research. In other words, things like topics nobody has talked about before. Maybe the existing research, maybe it has flaws. Is the existing research old? Has nobody looked at this in years? Maybe has it changed? Maybe the existing results, are they too narrow and they only apply just to one little situation? Or are they just massively wide in scope and you aren't sure that they're actually going to work in a certain situation? And maybe you should find out if they're going to work there. These are possibilities. So that once you've found some sort of goal to aim for, some sort of big idea that you want to try to address, you need to start thinking about phrasing a research question. Now this is a little bit of a complex thing to do, and we're going to talk about how to do it. So first thing you want to do, identify your independent variables and dependent variables. You don't need to be perfect about it. This is fairly rough, and you are going to, as I'll mention a little later, you're going to rewrite these things many times. So identify as best you can your independent variables and your dependent variables. Then start writing a few basic questions. When you start writing these, don't worry. They need to be basic. So if they're stupid, dumb, obvious, ridiculous, poorly phrased, whatever, it's fine. Your first few attempts at writing research questions will stink. When I write research questions, my first few attempts really stink. I don't actually ask what I'm looking at, what I'm looking for, why I'm looking for. These are just ideas you're getting down. You'll refine them as you go. Now, when you talk about refining these, you're actually in the humanities type research that we are doing here, you're going to redefine them and redefine them and redefine them again as their study progresses. This approach doesn't always sit well with people. For example, In the medical sciences, if you think about revising the research question, people say, no, you can't do that. See, Dr. Jones over here, she will give you a very, very stern look and say, no, 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 you can't do that. If you change your research question, no National Institute of Health funding for you. You will not get that multi-million-dollar grant. Why is that? Well, this is because this is clinical research that is highly controlled. So things like medical science, the lab sciences, physics, these follow a framework called the PICO framework. These sort of studies demand that the research question and design, they have to be, well, perfect before you get going. So briefly to talk about what PICO means is this. You got to talk about the population at hand. You got to talk about whatever you are doing to or with that population. You are describing the comparison that you are doing. You are looking for some sort of outcome that's your dependent variable, and the type of study that you were talking about. So, for example, one that I did a little search, and the National Institute of Health suggested this one as an example. In adults with chronic neck pain, what is the minimum dose of manipulation necessary to produce a clinically important improvement in neck pain compared to supervised exercise at 6 weeks? Well, that's a really good research question, but it's also way beyond the sort of stuff that we are going to be doing, not only in this class, but just generally in the kind of research that we do as technical communicators, or really anybody who is not in these highly constrained medical sciences. Instead, we are working in the humanities, or at least next to the humanities, and our research process works differently. So you remember the scientific method? You learned about this at some point in your life, and this thing is awfully close to the human-centered design process. We look at what's going on in the world. We figure out, maybe here's what's going on with it. We build a prototype, or we formulate some sort of questions and hypotheses. We test those prototypes or hypotheses. We observe the results, and then we see what happened, and we go from there and repeat to make more observations, think of more interesting questions, ideate, prototype, put together these hypotheses and questions. So it's very, very similar either way. Now, the reason I'm bringing this up is that in the humanities, we don't do strict experimental research. It's just really not possible to do. So we can't control all the variables all the time, nail things down. Matter of fact, a lot of what we do is fairly, quote-unquote, squishy, because we are dealing with real people doing real things in the real world. Instead, we're going to backtrack, rethink, and revise on the fly. So if we look at this scientific method, I'm going to say, all right, I'm going to make an observation. What do I see going on in the world? Ah, yes, there's an interesting research question. Well, I'm going to make a hypothesis, and I'm going to test that hypothesis. Well, maybe as I am testing the hypothesis, I realize, wow, my question is terrible. I need to go back and change it. Well, you can do that. Maybe as I'm formulating a hypothesis, realize, you know what? This hypothesis is telling me my question is terrible. I need to go change this. Or look at my hypothesis and say, you know what I'm hypothesizing here, I think I've seen in reality. Maybe I need to do some more observation and see what's going on in the world and think of a better question. Or after I'm doing the test, I'm gathering data to test predictions. Well, okay, cool. At that point, I may need to go back and, as the cycle says, refine, alter, expand, or reject my hypothesis. But I might also need to go back and say, well, my question is bad. Or, I need to make some more observations. Or, well, gee, I don't know. The point is, at any point during here, I can jump back and forth and revise things as they go. We in the humanities, we backtrack, we rethink, we revise our studies on the fly. So our research is rarely clean and simple. And one of the words that we used a lot when I was in grad school talking about research was messy. There is a lot of work that goes into it, and a lot of times the results that we get just are not entirely satisfying because they are real things happening in real time in the real world. They're hard to nail down. But let's get back to where we left off. Talk about phrasing research questions. So yeah, we're going to identify our IVs, we're going to identify our DVs. We're going to start writing a couple of basic questions. We are going to be happy about revising them as we go. So let's talk then about actually phrasing these research questions. I'm going to give you a couple of ideas here about how this can work. I'm going to give you some formulas. So if the IVs are nominal, remember nominal means sort of category type variables. These are not ordered in rank, number, or anything of the sort. Then I've got a formula for you to use. Is there a difference between independent variable A and independent variable B as shown in this particular dependent variable? Now, let's go the other way and say ordinal variables. If the IVs are ordinal, then try using this formula. Is there a relationship between independent variable A and this particular dependent variable? Please note, these are starter formulas. You will need, you will absolutely have to rephrase these things in order to make them make sense in ordinary English and be understandable. The point is here that we've actually got just this formula you can plug things into. Then once you've got the ideas down on paper or pixels, at that point you can start to rephrase. At least you've got the ideas in places where you know what they are. So once you've phrased a research question and got it decent shape, then you're going to start phrasing some hypotheses. Very similarly, I'm going to give you some formulas. So if the independent variables are nominal, I've got two formulas for you. One is for a two-tailed. Remember the difference between one and two-tailed? Two-tailed makes no particular prediction. It just says there's a difference of some kind. A one-tailed says that there is a specific difference, either greater than, less than, something of the sort. But let's talk about this. So if you have an independent variable with a nominal variable, you can say a difference exists in dependent variable A with respect to independent variable A and independent variable B. Or, to make a one-tailed test out of it, independent variable A is greater or less on dependent variable A than with independent variable B. If the independent variables are ordinal, try using these formulas. For a two-tailed, you can just say independent variable A and independent variable B are related. For a one-tailed hypothesis, you can say there is a positive or negative relationship between independent variable A and dependent variable A. Please note, when you look at these, are these correlative or causative statements? Think about that for a second. Try to answer it. Are we showing correlation or causation? The answer? Correlation. Now, it is possible to show causation, but it's actually quite difficult. You need to get some, well, not sure how to say this in the best way, but you need to get some statistics behind it. You need to show that something always happens if you're going to talk about causation. Most of the time we're talking about the kind of research we're doing, we're usually doing correlations. So at the very least, there can be a strong link between something that happens and a result, like they always happen together. Okay, cool. Can you prove that one causes the other? Often not necessarily. So the point is here, when you are starting to write your hypotheses, lean toward the idea of correlation rather than causation. And again, these are starter formulas. You're going to rewrite the hypotheses that you come up with. These are, once you plug in the stuff into these formulas, you're going to need to rewrite it so it makes sense in ordinary English. And that's how we write research questions and hypotheses. So that's pretty abstract, though. I think what you are probably looking for at this point are some examples to help make it make sense. Oh, yes. Well, tell you what. Since you asked so nicely, let's do this. What I've done is I've gone out and I've found an article. You can use it as an example/guide. So this particular article by Lauer and Sanchez from 2023, What Eye Tracking Can Show Us About How People Are Influenced by Deceptive Tactics in Line Graphs. The IEEE Transactions on Professional Communication is one of the major journals in technical communication. It is volume 66, issue 3, pages 220 through 235. Now, we aren't really going to look at this article closely, but the point is, I found this thing, And I'm using its ideas and the research questions in it and the hypotheses in it as a rough guide to show you what's going on. Now, in the article itself, I'm not super in love with all their hypotheses. I'm not really over the moon about the way they phrase their research questions. Point being that this can be challenging. So even people who get things published, readers who look at it may say, you know what, I don't like that a whole lot. You could have changed it, but doesn't matter. Point is, they did a pretty decent job. They got some decent questions. They got some decent hypotheses. And we're going to use these as a springboard to go forward. So in any case, let's take a look. Inventing a topic. Well, you know what? In the world, there are a lot of line graphs out there, aren't there? You think, yeah, we see them all the time, and particularly in technical communication, we see them. And a lot of them are pretty bad. For example, this last one that just popped up. But how do people actually deal with these? What do they do? What if these things are misleading? And as many of them are misleading. So how do people deal with them? We aren't entirely sure. So maybe this is a topic that needs some attention. Well, we've got this general topic then. Let's invent some research goals. What sort of things do we want to talk about? So, what exactly is the problem with line graphs? Stuff? Yeah, sure. We know that there are problems with line graphs, but what sort of problems are there? Well, in order to find that out, maybe you should look at the professional literature, do a lit review, find out what have other researchers said. And when you do find those things, maybe those researchers found some problematic areas. They have identified issues that you can follow up for your own study. Remember those possibilities we talked about? Finding the gaps in the literature. So, this fellow thinks that you have come up with a really good idea. So, let's go ahead and do that literature review. Search, Google Scholar. We're going to go to the library. We're going to look through journals. Well, realistically, you probably don't have to do it in person anymore. But the point being, you're going to look and see what's out there in the existing professional literature. So, you did this. Hey, I did a literature review, and here's some of the stuff I found. Now, those of you who are really observant will notice that these citations are not exactly in the format that you are familiar with. They are not an APA. Yes, they are following the IEEE format because this article was published in the IEEE journal. IEEE citation format is the devil as far as I'm concerned, but all the same, I didn't really want to go ahead and rewrite all these into APA, so here we have it. But I did my literature review. Here are a bunch of sources that all talk about problems with line graphs. So, what do these sources have to say? They say that line graphs contain lots of deceptive tactics. Nobody has ever used eye tracking software or eye tracking data. There is such a thing. You put on the little headset and you can plop somebody in front of a computer and see where their eyes are going on the screen. This is kind of cool. So, nobody's ever looked at using eye tracking data to analyze how users deal with deceptive tactics. That seems like it might be a good thing to do. Oh, how about this? Titles and captions. They seem to affect how users interact with line graphs. So maybe I can do a study that combines line graphs, eye tracking software, and titles and captions. Cool. All right, so it's time to start writing a research question. What do I do? Okay, I need, independent variables and dependent variables. Right. Wow. What are they? Well, what the answer is this. What can you manipulate, and what can you measure or collect? What you can manipulate, those are your independent variables, and what you can measure or collect, those are your dependent variables. Now, I'm saying manipulate. These are conditions maybe that affect an outcome, but because we are going to be doing sort of a quasi-experimental study here of taking some participants and giving them a treatment, making them walking them through a process, I'm going to say manipulate. But let's talk about what these things are. I can manipulate if a graph is or isn't deceptive. So I can make a graph that is not deceptive. I can make a graph that is deceptive, and I can give them to people and see how they do. Okay. I can put a title on, or I can leave a title off the graph. I can change the title's contents. I can make it really simple, or I can make it some sort of overblown and exciting thing. Maybe I can tell participants what to look for, or maybe I don't tell participants what to look for, or maybe I'm going to ask them, well, I think I'm going to ask them questions about this. So, if I do this thing and say then at the end, hey, tell me about what you just saw, if I tell them that I'm going to ask them questions, they're probably going to act differently. So that's an independent variable right there. I can say, I will or I won't tell participants I'm going to ask them questions about the graph's meanings. Now, what sort of data can I collect? Well, I can collect where users look on screen. I can use the eye tracking software and hardware. I can time how long the user looks at various locations on screen. And I can also collect the user's statements about what the graphs mean and evaluate their words. Okay, cool. Notice these independent variables. They are all nominal. I'm not actually using anything that is a number or a sequence or anything of the sort. So from this point forward, when I start talking about writing hypotheses, writing research questions, I'm going to use the nominal formulas. So let's then write some tentative research questions. Now remember, we're going to use a formula. We're going to plug in. It's going to just sound really, really weird, but we can rewrite it. So let's get started. Is there a difference between IVA and IVB as shown in this DV? Well, this is the formula we have for nominal independent variables, so we're going to run with it. So let's plug in. Is there a difference between deceptive and non-deceptive graphs, as shown in how users interpret the graph's contents? Well, there's a possibility. How about this one? Is there a difference between telling the users what to look for and not telling them what to look for? That independent variable, two different conditions, as shown in how long the users look at specific areas of the graphs, my dependent variable, thing I can measure. Here's another possibility. Is there a difference between simple and exaggerated titles? Simple title and exaggerated title, two different categories, or I shouldn't say categories, two different examples of conditions of an independent variable, as shown in what participants say about the graph's meanings. Oh, there's some dependent variable that I can gather. So these are some tentative research questions. Now notice I'm just plugging in my words that I'm using for independent variable and dependent variables. So let's get rid of some of these and rephrase one of the research questions so it's actually readable, understandable in English. You don't have to bend your brain. Let's focus on this one. I'm going to move it up top, take out the bolds, and we'll just go from here. So is there a difference between telling the user what to look for and not telling what to look for as shown in how long the users look at specific areas of the graphs? What does this actually mean in English? I could rephrase it a couple of different ways. For example, I could say, how much attention do users pay to various areas of the graph when they do not receive instructions about what to look for in the graph? How long do users look at individual areas of the graph when they are not told what to look for in the graph? How long do users look at the elements of the graph when they're not forewarned to be asked questions regarding the graph's meaning? That one's a little bit different, isn't it? But all the same, it folds in pretty well, so I'm going to go with it. Point being here, there are a bunch of different ways that you can rephrase this formula question, and each of these ways that I have put it here on the bottom of the screen, each of them works fairly well. It's up to you to just rewrite and rewrite until you find one that makes sense. So we've got a research question, or three. Let's formulate a hypothesis, or maybe two. No, probably just one. Let's see what we do here. If the independent variables are nominal variables, use these formulas. These are the ones I gave you before for the two-tailed and one-tailed. So because we have nominal independent variables, I'm bringing up the original research question that we wrote, not the revised one, but the original one with the highlights to emphasize that these are the independent and dependent variables we're looking at. So let's take this, and then we're going to make a one-tailed hypothesis. I'm going to do a one-tailed because two-tailed is kind of weak. I mean, It's essentially saying, yep, something's going to be different. Well, sure. That's not exactly a big surprise. So if you can find that it is going to change one way or the other, that's a far more compelling. So you can write two-tailed hypotheses, but if you can, try to go for a one-tailed. So we've got the formula up top. We've got the plug and chug version below it. Let's try to rephrase. So H1, so this means it's my first hypothesis. Telling the users what to look for, that is my IVA, will increase, so it is greater than the length of time users spend looking at the graphs. That's my dependent variable. Than with IVB. So I'm going to say then, rephrase it so it makes sense in English. This time will be greater than the length of time users spend looking if they don't receive reading instructions. So telling the users what to look for will increase the length of time users spend looking at the graphs. And this time will be greater than the length of time users spend looking if they don't receive reading instructions. Well, it's not bad, is it? But I think I can make it even better. So I'm going to rephrase and say, users who do not receive instructions on how to read graphs or what to look for will read the graphs faster than users who receive specific reading instructions. That's a little easier to read, isn't it? So the point being here, you can take these independent variables and dependent variables, plug them into the formulas, and just, once you've got them there, rephrase until it's clear what exactly you're talking about. So to review, we have actually invented a research topic, we've invented research goals, we've phrased research questions, and we've got a hypothesis together. Now, you may be feeling a little bit overwhelmed at this point. That is okay. Don't worry about it. The big deal is that you are competent. You can do this. You just need to identify your variables. What are your independent variables? What are your dependent variables? Follow the formulas. Plug and chug, then rephrase what you got until things make sense. You can do this. That's the end of this video lecture.